Okay, let's examine the half-life for a zero-order process. We know if we have a zero-order process, we can use the integrated rate law. A final minus A original is negative KT. Well, if the time that we're talking about happens to be the length of a half-life amount of time, then I can substitute in for the time here the symbol for half-life, which is K, and then the half-life symbol is T1 half. So we have got our time as an amount of a half-life. If we go through one half-life, what we know is our final amount will always be half of our original amount. I'm going to plug that in for A final here. My A final is 1/2 my A original amount. And then I still have this term minus A original. Now I'm going to go ahead and do a little bit of algebra. 1/2 of A0 minus a full A0 is negative 1/2 A0. I'm going to simplify and just write that as is. Negative 1/2 A0 equals negative K, and this is our half-life, T1 half. Now we have negative signs on both sides of our equation. I'm going to go ahead and get rid of those negative signs, make them positive. And the last thing I'm going to do is isolate my half-life symbol right here. And to do that, I'm going to divide both sides by K. So I get an overall equation for my half-life of T1 half equals A0 on the top over 2, and then we've got our rate constant K. So here is the equation for the half-life of a zero-order process. Now, things you should note about this equation. First of all, your half-life absolutely depends on your amount. If you start to decrease the amount of reactants that you have, that will mean that your half-life will steadily go down. So, for example, look at the graph of concentration versus time. If we notice, we start with a concentration of, let's say, 100 grams. Now, as we go ahead and go through our first half-life, that amount will go from 100 to 50. Okay, that takes a certain amount of time. Well, in the next half-life, we have to go from 50 to 25. Since we're plugging along at exactly the same rate, it always goes through a certain number of molecules a second, molecules a second, molecules a second. Going from 100 to 50 is a bigger change than having to go from 50 to 25. So 50 to 25 takes less time. The same thing will happen if we go through our next half-life. Going from 25 to 12.5 will take less time. So your half-life steadily decreases as your concentration of reactant goes down. I hope that helps. Take care.